Hello and welcome back to TensorFlow. In today's video, we are going to solve lead code problems of the topic array. So these are data structures and algorithm problems. So we are going to solve them one by one. So the first problem is sum, which is a very famous problem in lead code. So this is the problem and we have to solve it. So first we will read the problem very carefully because sometimes we read the problem but we don't understand it correctly. So you have to read the problem very clearly so that you can understand the problem, and if you don't understand the problem, you will never be able to solve it. So let's read the problem. Given an array of integers nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So basically the question is saying we have an integer nums, and we have to find the two numbers which add up and get equal to this target. So and then we have to return the index position of those numbers. uh, like in this case, 2 and 7 add up together to make 9. So we have to return the index position of 2 and 7. So the index position of 2 is 0 and the index position of 7 is 1. So now as you can see in the example number second, 3 2 4, this is the integer array and the target is 6. So if we will add 3 with 2, it will be equal to 5, and if we will add 2 with 4, then it will be equal to 6. So we will return the index position of 2 and 4. So now for every problem there can be many solutions in lead code. So like in this problem, you can also solve it using brute force. We can start two loops, and one by one we can check, like if in first loop we will take this as our number, and we will add this number with every other number in the array, so that we can find if this adds up to any number and return 9. Oh, sorry, add up to any number and its sum will equal to 9. So we will return the index position. So now let's write the brute force approach first. So for brute force approach, we will start two loops. One will acquire this element, the first element, and then second element, and then so on, and compare it with all other elements, add with all other elements and compare it with the target. So for this we will start first loop for I in range of length of nums minus 1, because we will iterate only to this target. Now for now we will start the second loop. We will use nested loop here. So for j in range of, now we want to compare this element with this, and we want to compare the first element with the second to the last element in the array. So we will start this loop from I plus 1 till length of nums. Now we will cover if if nums of I plus nums of j is equal to target, then we will return the index position of these two numbers, which will be I comma j. And if we will not find any number, then we will return the empty array. Now let's run the code and see. Yeah, so as you can see, it is our code is working well, and it is solving every test case. Now this approach is the solution, but this is not the optimal solution, because in data structures we look for the optimal solution of the problem. So the time complexity of this loop will be equal to big O of n square, because we are using nested loops and we are using two loops here. So the time complexity of this problem will be n square. So now we will erase this solution and write another solution. So read the problem again. Now we want to compare the first element. We want to compare the first element with every other element in the array. But the optimal approach could be if we will store all these elements with their index number in the dictionary. So we can easily find that if the complement of this number exists in the array, so we will easily return the index position of that element. So let's create an empty dictionary here. So this dictionary will hold the numbers and their index values. Dictionary contain keys and values, so we will use keys as the element and values as the index numbers. So to do that, we will use a for loop for I in nums. For I in, we will use enumerate function here. So enumerate nums I comma j in enumerate nums. So this will give the index position, and this will give the number of actual element of the array. So now we will store d of j equal to I. So we are storing every element and their corresponding index in the dictionary. Now what we have to do is, now we have to compare that if the first we will calculate the complement of this target, which means we will first calculate that what is the number comes when we will subtract 9 from the first element of the array, which means we will subtract target from the first element, and then we will find the complement. If that complement exists in the dictionary, we will return the index, which means first we will calculate 9 minus 2, which is 7, and then we will find 7 in the dictionary, and if we will find the 7 here, then we will return the index or the value of that key in the dictionary. So to do that, we will use another for loop for I in range of length of nums. Now first we will calculate the complement, which is c equal to target minus 9. Oh, sorry, target minus the first element of the array. This will give the value 7. For this example, this will give the value 7. Now we have to find if c exists in D, then we have to return the index position. But there could be a case where c and the value of c and the first element will be same, because the complement value and this the first index will be same. So we have to handle that case also. So to do that, we will also check that and the index number of that complement is not equal to the index number we are searching for, which means d of c is not equal to I. So now if this case is true, then we will return the index position of uh, the first element I and the index position of this element, which is d of c. And if we will not find any solution, then we will return the empty array. Now let's run the code. So as you can see, this is the optimal solution of the problem, and now we are getting 51% accuracy, and we are doing this problem in 3 milliseconds. Although this don't show the accuracy of the problem. If you will submit it again, it will change this percentage. Please try again, few seconds. Okay. So this is the optimal solution for the problem 2 sum. In next video, we will solve other problems of array topic. So thank you for watching, and stay tuned for the next video, guys.